Perturbation theory in quantum chemistry. Perturbation theory is an approximation method. Consider the case of an one-electron system, that is hydrogen atom. In this case, we get the exact solution of Schrödinger equation. But in the case of multi-electron system, the Schrödinger equation will split into n equations. So, we didn't get the exact solution. In this case, due to inter-electronic repulsion, there will be uncertainty in the Hamiltonian. So, we are using the approximation methods by which we can determine the value of energy approximately. Perturbation method is an approximation method. Amongst the approximation methods, the simple and most interesting is wave mechanical perturbation theory developed by Schrödinger. It is a technique of arriving at energy and wave function for a system for which Schrödinger equation cannot be solved. The meaning of perturbation is disturbance, that is certain disturbance in the system. Consider the case of a non-dimensional box. In the case of a non-dimensional box, the potential is zero everywhere inside the box and infinite outside the box and at the boundaries. In this case, the system is disturbed. That is, in this place, we get a correction of energy. That energy is added to the exact value of energy and we get the approximate value of energy in this case. In perturbation method, we have to find out the correction in energy value. Next is the perturbation corrections. We can divide the total Hamiltonian into two parts, that is H equal to H0 plus lambda Hn. H0 is the unperturbed system, that is it will give the exact solution of Schrödinger equation. This part, that is H1, is the perturbed parts. Lambda is the quantitative parameter. When we are considering the n-electron system, the Hamiltonian for the unperturbed system is H0 and the corresponding energy values are E1 0, E2 0, E3 0, etc. etc. En 0. The wave functions are psi1 0, psi2 0, psi3 0, etc. etc. Psi n 0. So the multi-electron system can be written as H psi n 0 is equal to En 0 psi n 0. H equal to H0 plus lambda Hn. So this equation can be written as H0 plus lambda Hn into psi n 0 equal to En0 psi n0. Psi n is equal to psi n0 plus lambda 1 psi n1 plus lambda 2 psi n2 plus lambda 3 psi n3, etc., etc., etc. En is equal to En0 plus lambda 1 En1 plus lambda 2 En2 plus lambda 3 En3, etc., etc., etc. In this case, psi n0 En0 represent the zeroth order correction tape. This one. Lambda 1 psi n1, lambda 1 en1. This part. Lambda 1 psi n1, lambda 1 en1 represent the first order correction. This part. Lambda 2 psi n2, lambda 2 en2 represent the second order correction. First order correction is larger than second order correction, which in turn is larger than third order correction. The Schrodinger equation for unperturbed system is H0 psi n0 minus En0 psi n0. And for perturbed system, the equation is H psi n equal to En psi n. The value of H is equal to H0 plus lambda H1. That is when the perturbation is small. According to the first order theory, the value of En is equal to, that is En1 is equal to psi n0 H1 psi n0. That is the expectation value of the perturbation in the unperturbed states. On integrating this one, the value is integral of psi n0 H1 psi n0 d2, where H1 is equal to H minus H0. And the value of En is equal to En0 plus En1 when the value of lambda equal to 1. And the value of psi n1 is equal to sigma L not equal to n psi L0 H1 psi n0 divided by En0 minus El0.